Good morning, good afternoon, good evening, whatever time you are watching this. This is Sam Prentice Makes It Happen. I am Sam Prentice back once again making it happen, and today we are talking about the Big Tree Tech SKR 1.4 Turbo upgrade board on the Ender 5 Plus by Creality, and also how to install the Hemera by R2-D. So let's get straight on into it, shall we? We're going in deep with this one, so please pin your ears back because I am about to begin. This is the SKR 1.4 Turbo board by Big Tree Tech. I'm just removing the jumpers to put it into UART mode and install the TMC 2209 stepper drivers. And with these particular drivers you will need to bend the diag pin up in order to activate stall guard. Stall guard, of course, being bump sensitivity on your 3D printer. So of course, once you've plugged all those in, you just need to open up the back of your printer, and what I'm doing in this case is just making sure that everything is coming out at the correct voltage, which of course is 24 volts on this printer. If you're in the market for buying an SKR upgrade board for your Ender 5 Plus, I would also suggest that you do check out Tripod's Garage. There's a chap called John. He's a really good guy. He's got a super detailed video on how to install this board and also update the Marlin software as well. However, as always, I wanted to do something a little bit different. So the upgrades for the SKR Turbo board are the TMC 2209s, the Wi-Fi chip and the R2-D2 Hemera direct drive. At this point of the video, I'm going to be rewiring the BL Touch. You do need to have a relatively good understanding of electronics and working out exactly how diagrams go together, and I will quickly show that here. So this first document shows you from the very top the fact you have a fan plug-in, you have an X, Y, Z, a second Z, the extruder 0, extruder 1, and then another fan. On the right hand side you've got the LCD plugs 1 and 2. Then you've got a power detect, reset key, you've got an E0 detect. Along the bottom you've got your thermistors, you've got the EPS module is the Wi-Fi, you've got your SD card, you've got your normal plugs, fuses. To the left hand side, left hand bottom, you've got your DC in. You'll need to make sure that you've got the positive and negative around the right way. You've got your heat bed and you've got HE1, HE2, which are basically for your hot ends. And then we've got another fan, and in fact there's two fans. There'll be one for the both for the hot end, and one will be to cool the heatsink, the other will be to cool the filament. On the lower right then you've got your BL Touch, you've got a RGB plug for your NeoPixels, you've got a TFT which you'll need to plug in if you're going to be using one of these smart boards. You've got an ITC connection, an SPI connection, and then of course you've got your end stops as well, which will also be plugging in. I think there's only actually two on the Ender 5, because the other one of course is a BL Touch. Now the BL Touch cabling does need a little bit of rejigging, but it's relatively simple. All you need to do is unpick the pins and plug them in a slightly different configuration, and you'll see here, if I can highlight this, this is the pins. These are how it's set out. So on the servo pin you've got the ground, the power and a 2.0, and on the probe you have a ground and a 0.10. So if your brain has not melted, what does this mean to you? It means that the servo pin needs to be ground, power, signal, and the probe needs to be ground and 0.1 or 0.10. Now what this means generally is that on the left hand side it will be a negative, which in this case is brown. The middle will be your red, and to the right will be your orange or yellow cable, depending on what they've supplied you with. And the probe will generally be black, I believe, and white, which of course mean left and right. So now it's time to plug it in and see if it works. Okay, so here we go. Everything's in. We're very happy with everything works. Let's hit the button and see what happens. Okay, so no blue smoke as of yet. And at this point the card should have squirted the new software in, and I guess we're going to have to wait for a few minutes. There might be an EEPROM error. So if you press and hold down this button here, it should take us into the Marlin mode, which it is. But nothing's working at the moment. Okay, well the BL Touch seems to be doing a bunch of different things at the moment. Okay, yeah, so here's the EEPROM issue. Ender 5, that's cool. So what we're going to do then is quickly go into, I think there's a few settings here that I can mess around with. Now I'm just going to take this card out, and what you'll find is that this card should be changed from a .bin file to a different type of file, to a .cur file in fact. So let's just have a look in here, and somewhere in here there should be a configuration. So BL Touch is in there, that's good. Act recovery, yeah. Okay, advanced settings, let's have a look in there. Filament, initialize EEPROM. Right, let's do this then. Let's see what happens. That didn't sound very good. Okay, never mind. Let's see what happens now. Okay, it's still there. Right, I'm going to reboot this again. And let's see what happens this time. Now the card's out, of course. See if it boots back into it. Yeah, Cheetah 5.0. John, I thought there was going to be like a logo of you with hobbling about or something. Tripod's garage. Okay, well that's good because now we don't have the EEPROM issue, so that's absolutely fabulous. So moving swiftly on, E3D have just sent me some other bits and pieces, so let's open this up and see what we've got. My invoice. How much was that? Doesn't say. Okay, so a couple of things I wanted to order, mainly for this, I guess, is a 24 volt heat unit for my Hemera, which is that one, and also a 24 volt fan as well, because on my Hemera at the moment I've only got the standard 12 volt, which, you know, obviously won't work. So that's why I've got it. So thank you very much to E3D for pinging that over to me. So at this point I'm basically going to test everything on the printer just to make sure it all works as it should do. The BL Touch, sensorless homing, any of that kind of stuff that you decide that you want to install on this, this is the best time to do it, and that it's not going to crash into anything. You'll notice as well that this is the stock hot end at the moment. The Hemera is coming up, but the reason that it's taken such a long time to actually get this video out is because I had major problems getting that thing set up and configured, thinking it's one thing and in fact it being something completely different. So I'll move on to that a little bit later, but I am going to tell you how to do it and how to avoid the downward spiral of wanting to throw a 3D printer out the window, and of course maintaining British optimism at all times. And of course, ignoring my ramblings, you will have seen the BL Touch doing a fantastic and formidable job on levelling itself on the end of 5 Plus. And of course doing it silently due to the Trinamic TMC 2209 drivers from Big Tree Tech. So up next we have the stock hot end doing a print, and as you can hear it hasn't got that noise, which can only be formulated from a 56k dial-up or a ZX Spectrum if you're old enough to remember those. In fact, it's actually pretty good, and if you look back to the beginning of my video where I had the filament seepage coming out the top, it was basically down to whoever actually built this at the factory hadn't done certain things up properly, and even the thermistor was over tightened, which was causing a short to the board as well. So once I kind of figured out exactly what some of these problems were and how to fix them, this is kind of a good route forward if you're just looking to do the board, do the drivers, quieten the thing down. This is a good route forward, definitely, I would say, for you. If you want to take it that little step further, then, you know, go direct drive or change the hot end out for something that's a little bit less stock or problematic or has heat creep. Then there's a number of hot ends that are out on the market, but the one I chose to use on this particular model is the E3. It, dual drive, can be mounted as a direct drive. Mounting is easier than most. Its price point at £108. Core competencies mean that you can push the envelope when it comes to alternative filaments. 10 kilos of pushing power. And comparing this to the Bondtech DDX and Slice Copperhead, you're going to be paying 3 times the price for that other setup. In short, the Hemera could be a clear winner here if it wasn't for having to mod the code, and if you had to do this as a novice, I would have concerns. But let's not forget about our friends at K3D that offer an awesome bit of software that you can easily make changes to Marlin without having to do too much more than download and change a couple of bits in the code, and of course read. I will leave a link to my GitHub with my settings for this build, along with John's link for his SKR and K3D link, if you haven't already used a search engine to find it on Google. So what's the Marlin code change? Well, I'm glad you asked. The hot end steps need to be changed to 409, the thermistor needs to be set to number 5, and that's pretty much it. So what are the issues that I had? Well, I did have my first sense of humour failure this year with this particular hot end. After the install, I heated the hot end up, but was not able to reach more than 150 degrees before it errored. To which I said, it's got to be software, right? Well, after several calls to E3D, replacing various parts on the printer, namely the heater cartridge and thermistor, PID tuning so many times that I now suffer from repetitive strain injury, I thought that the hot end was just basically going to be my next paperweight. After a week of trying various methods, I figured I'd have one last attempt. So I broke the unit down and rebuilt it, moving the nozzle and the heat break. Now the fix was to move the nozzle in and the heat break out. And it's a fix. I then had a clicking sound coming from the unit, but soon figured out, and I can honestly say it's now running like an absolute dream. So once again, little word of warning here, if you do have any issues with this thing, I would suggest you take it apart, put it back together again and see what you get afterwards. So to be clear, the issue that I had was the fan appeared to be cooling down the heatsink so much that it wasn't able to reach temperature. Obviously taking it apart and rejigging the nozzle and the heat break was able to solve that issue. So next I wanted to upgrade the fan. I only had a 12 volt version of the one that I had, so I used a buck connector to basically half the voltage. I'll put the link in the description for that as well. Nice one, Amazon, thank you. So we're about to move on to the first print. Thinking about this printer and the upgrades, also thank you to Creality for sending me this printer, only for me to then rip it apart due to the noise in the hot end, but thinking to myself, why don't I just build my own printer? Well, here's the answer. The Ender 5 Plus is a solid printer, and in fact both the Ender and the CR10 range have great usability for the majority of the market. Upgrading the hot end reduces the risk of blockage issues and heat creep that standard blocks suffer with. In addition, the 32-bit board and trinamic stepper drivers not only reduce noise, but also should improve the calculation of the curves and arcs, acceleration, print quality, and of course there is room to grow and escape the basic boards from the manufacturers that don't allow board mods. And at the moment I'm at the stage where the E3D Hemera is very much a working product, but it still needs dialing in and tuning a little bit in order to get that sweet spot. In addition to this, Facebook and the online community for 3D printing have been a fantastic resource with making sure that I'm able to do these kinds of things. Again, John at Tripod's Garage has been a massive influence on actually upgrading this thing, and he's helped me a lot with this kind of stuff. So make sure you check out his channel. I'll put the link in the description once again. So in closing, these are my final hints and tips. Number 1, ensure that your cable length is long enough to reach the hot end. In a standard configuration for a direct drive, it will not be long enough. Number 2, consider the mods that you want to undertake and carefully plan. For example, which fan print files will I use? Number 3, decide on the upgrade path stages. For example, do I just do the board, screen and drivers and do the hot end later? Number 4, what other upgrades will I do in the future? Perhaps Core XY. Number 5, do I know what I'm doing and have the confidence to deal with problems when they arise? Number 7, do I have the tools to undertake the job? The ones that come with the printer will probably round off, and a decent multimeter and soldering iron certainly wouldn't go amiss. Finally, number 8. Research. Tripod's Garage is an excellent source of in-depth upgrades on the SKR board, and of course you can message me and I will always help where I can. If you're looking to mod your Marlin code using Visual Studio Code, then really it's not a 5-minute job, it's not a 5-minute video to go through this, but simply put, just download your K3D Cheetah 5 software and read it. It will tell you exactly what you need to change depending on which setup you have. They have a number of different ways of working it out. But of course, if you are copying something that you've seen on YouTube, hopefully they will also supply the .bin file, so you can literally download that file, put it on an SD card and plug it straight into your printer, and hopefully it will work without too many issues. Thank you again to John, Big Tree Tech and Creality, of course, for supplying me with this printer, and good luck with your upgrades. So it really is that simple. Thank you very much for watching, and leave any comments in the description below, and don't forget to hit that subscribe button. See you next time.